Let's write down the units for these things. So I'm going to start with temperature difference. What are the units for temperature difference? If you're wondering, you're not a psychic. Yeah, in the question somewhere. Okay, yeah. Celsius, very good, Shazad. You can also use Kelvin. See, it says Celsius or Kelvin. So I'll use Kelvin, but Celsius is just as good. I'll put C or K. Okay. Now, what is the formula for heat flow? Just look for it in the question, because basically you're just being a scavenger right now in the question. Heat flow is right here. Watts. W is watts. So that's pretty much it. The only one that's missing is this one. K. That one's messed up. Anybody want to take a stab at what the units for K are? That's a tricky one. It is a constant for a given material, but how would you find the units for K? This is why I want you to get used to seeing questions like this, because you can derive the units based on the formula here for K. So I'm going to take this formula for K, and I'm going to mess around with it for a little bit. So if you notice, the units for K are QL over A delta T. Q was units of watts. L is units of meters. The units may be derived, yes. I'm kind of reading your responses, but I'm just targeting the ones that are most relevant to the solution, I think. So if I use temperature in Celsius, so let's put it in Celsius, okay? Actually, I'll use Kelvin, because you could use either. So I'll just use Kelvin. I'll put it in green here. But you could have Celsius as well. So what does this simplify to? Watts over meters Kelvin. That's the answer. All right, that was a bit of a pain. Anyway, I know that we're kind of approaching the break soon, so maybe we'll finish off this example after the break. If this question scared you, I just want you to put it out of your mind, as it's not going to be impacting your tests or evaluations for this semester. So these questions with the formulas are just out there to help you explore and think about things on a broader level. Let's try to calculate L. The funny thing is that L has the exact same shape as Q. See, it's QL. So this time I'm going to divide both sides by Q. But you see how Q and L behave the same way. When you see like a pattern with the variables, take advantage of it. So what I'm trying to say here in short is that, do you see how Q and L appear on the same location? They're on the top in the fraction. That means that when you rearrange them, the response or the formula will look similar. See, we have Ka delta T both times. So that's a key that you can compare them. Let's try this next one here, which is the solution for the area or cross-sectional area. This time I have to divide by K and delta T on both sides. So let me get rid of those guys. Let me see here. So we're going to divide both sides by, we said K and delta T. And you can play this game again. You notice how that in this equation, A and delta T are in the same position? in this equation, you can take advantage of that, and you can actually just switch them. Now, I'm just showing you little tricks that I use, and of course, if you don't like what I'm doing, you can definitely play other games. I talked to you about in week 1 how you can switch things diagonally, and you don't wreck the equation. So now comes the question. So, sorry, that's the end of you, in a sense, dissecting the formula, or just kind of figuring out what it's all about. Now, another second thing we could do is actually take the formula for like a test drive. So now you know what's under the hood. Why don't we take it for a test drive? And that's what the question 23 is about. And that's how a lot of the questions that I'm showing you in this booklet are, in terms of the formulas. First, I make you build the table where you basically dissect and figure out all the things about the units, the symbols, the equivalent ways you could write the equation, and then we take it for a test drive. See? Numbers. Fun. So let's take a look if we can actually do something useful with the formula. This question, no doubt, is straight out of a building science quiz or a problem set. So you're really preparing for a different course, but hey, why not, right? Have some fun here. Okay, so what you want to do is first figure out which of the quantities that you're trying to solve for. In this question, what are we trying to find? Are we trying to find thickness? Are we trying to find temperature change? Yeah, we're trying to find K, because we're trying to find thermal conductivity. So there's the formula for K. So I'm just going to copy the formula. It's the only formula that I didn't actually type. That kind of sucks, but whatever. Q, L, A. So the next thing that I would advise you to do is figure out if you know all the other information. So do you know Q? Do you know L? Do you know A? And do you know delta T? Hopefully we have all these things on standby. So let's go through the question. Do we know Q? What's Q here? Well, if you don't remember what Q means, that's why you have the table. Look at that. Right in front of you. See, Q is heat measured in watts. So look through the question and look for watts. Do you see watts anywhere in the question? Yeah, 40. Thank you, Peter. So it says 40 kilowatts. So we have a little bit of a hiccup there. So we know kilo means 1,000. That's 40,000 watts. You could put a comma in there. That's fine. I'm not going to put any punctuation. I'll just leave it like that. So I'm going to go down here, and I'm just going to start to set up my formula as we see the thing. So we know Q is 40,000. Like a little checklist. Okay, L. L is the length of the actual, or the thickness, I should say, of the material, as mentioned here, and it's in meters. Do we have meters here? Yeah, we have meters. Okay, so that's 2.28 meters. And then the area, the cross-sectional area, look at that. It's in square meters. Now imagine that you're in building science class, and they're like squared centimeters. So you know what we did in the first hour, we converted from square centimeters to square meters. You're going to play that game. So that's why we're doing this, so that the unit conversions earlier are going to pay off here, or at least in the future. I keep on talking about building science. I'm not trying to scare you. It's just a course that involves a lot of calculations, and students tend to take a little bit more of a challenge out of it because they don't, I'm not saying you guys, but sometimes students don't take it as seriously as they should in the beginning. And then what happens is they get overwhelmed by formulas, and then they're like, get scared or whatever. But don't get overwhelmed. If you try to do what I'm doing here with like dissecting each formula, like each week you might learn a couple formulas. Each week make it your mission to understand what those formulas are and how to plug in all the stuff, and also to make sure you don't screw up the units. So pay attention to those units. Speaking of which, the temperature difference is 35.2 Kelvin. That just means that our value for K will be in kelvins down up here. So we're going to have this answer. We could also have Celsius here. I forgot to write that earlier. Oops. I can't put the degree symbol. This program is very funny about putting the degree symbol, so you'll have to forgive me for that. Anyway, the A is 6.53, and the temperature difference is 35.2 Kelvin or Celsius. Thank you. So it doesn't mention accuracy here, but we should put some accuracy. So I'm going to go with 3 significant digits, if that's all right with you. Anybody have a number on that? Anybody have an answer for this? Yeah, 397. Nice, Mario. 397 watts per meter per Celsius. So anyway, that's just a nice question where we actually go through and just absolutely steamroll a formula. And there's other formulas that we cover in the previous classes. Thank you, Ravina. And there's other formulas we covered in the previous classes where that I covered with the previous classes that I'll post on YouTube, like I said. Anyway, I wanted to try one more, and I feel like it's probably one that we don't need to really do because it's just kind of the same game. So I'm not going to cover it. Yeah, it's better that we don't cover it. I think we're just going to go to surface area and volumes today. Yeah, let's do that. Okay, so these questions here, 24, 25, I covered these on Thursday with one of the sections. 27 I covered with a different section. We could do, yeah, we did this one on Tuesday, so that's already a video for that, you can see. So basically all of our ducks are in a row here. This one here I didn't cover with anybody. We can definitely cover it together, but I don't want you to I don't want you to get too intimidated by the actual question. This question is we can actually just maybe rearrange the formula and leave it at that. So let's fill in this table, but not do the actual calculation part. Luminosity. So what the heck is luminosity about? Why would you care about this? Any thoughts? Luminosity. Brightness. Windows. Yeah, actually, I think I like your comments, Victor. That's a very solid comment there. Windows, because you're talking about energy transfer through radiation. I don't mean radiation like X-rays and zapping people like a sci-fi movie. I'm talking about radiant energy from any radiant source. Even let's say that you're at a campfire and you put your hands out to the campfire, then that even the heat that is transferred to your hands, the energy, is something you could calculate. So what you have here is the formula for luminosity, which contains a few things. Luminosity, which is itself whatever the quantity that you're trying to find. And luminosity is a measure of power. So if you look through the question here, you'll see that luminosity is actually the rate of energy. I don't actually see that it says what the units are. So, but it says it down here. The luminosity is a measure of rate of energy, so it is the same units as power. So we know that power is watts. And if you didn't know power was watts, it's okay. It's just a very conventional unit for power. Surface area, you should know the units for surface area. In the metric system, it would be in square meters. And temperature is going to be in kelvins. So in this case here, it matters that the temperature is in kelvins. So, because the question explicitly states that it has to be in kelvins. This is because kelvins is a measure relative to absolute zero, and that's why it matters. In the previous question where it was delta T, like a change in temperature, it was difficult to compare the two with this one because change in temperature doesn't matter if you're in Celsius or kelvins. If you go by 2 Celsius, you also go up by 2 Kelvin because the shift is the same. Whereas temperature in kelvins is absolute in this case. So that's why it's a little bit different. So temperature is T, surface area is A. And now you can go ahead and fill in this equation manipulation here and figure out all the different versions. So the one that I'm going to focus on is T. I'm going to do the hard one with you, and then we're going to switch over and do some surface area and volume calculations. So these three here, I'm going to leave them for you as an exercise. I was going to fill them in, but I want to move on to the other topic that you're going to be tested on. So these three here, you can check out Blackboard for the answer. Let's take a look at solving for T. So I'm going to solve for T now. So look at T. I'll do the method up here maybe. How do you solve for T? What's your first step? What do you think we should do first? Any thoughts? You got to rearrange the L formula. So the first thing I did is I just wrote it backwards because I want T on the left. Now these guys here are multiplying T. The next thing that I want to do, is divide both sides by these three quantities. So I'm going to just divide them on the other side. And we're almost there. How do you get rid of the 4 here? That's a tricky one. Yeah, it's a quartic root. Well done, David. Yeah. Do you know when you have like this? I'm just going to jot this down up here just as a side note. When you have x squared equals, I don't know, 9. Make it 9. Make it like 13. Then x equals the square root of 13. It can equal plus or minus, but don't worry about the plus or minus here. I'm not going to write plus or minus. I'll just highlight that in a separate color to like not emphasize it as much. The idea is that the order of the root is 2 because the power was 2. So that's why we have, or yeah, to the 1/4 as well of Ravina. Those are both answers are correct. I'll actually state both answers here. So T equals, so option 1 is you could write it as, where's my equations? You can write it as a 4th root of that stuff. Option 2, which are both correct, you could also raise it to the power of 1/4. Either option you choose are correct. And of course, when you look at my solutions for these on Blackboard, you'll see that I think I chose the first one. I used the actual root operator.